here, welcome to our second in our series. This one's all about agentic applications and building out security. Who let the agents out? Your client ID is not an identity. And what does that all mean? So we're going to dive into the topic of security. Here at Diagrid, we are all about making agents reliable and secure. We love reliability, we love security, and what we want to dive into and talk about today is what is it that you are experiencing with production security challenges. We spend a lot of time talking to people who are building agentic applications, and we hear a lot about security as an element inside that, along with these other words inside here about production. So we'd love it that if you could just post in the chat channel things that you would love us to answer. And literally, it's a free for all, your own. Yes, I mean, no, don't hold back on what you think you need to solve from security perspective.
You know me, I'm not holding back ever.
We want whatever you think you want to cover. We probably heard it. We could probably address it. And we're really excited about talking about security generally in these agentic systems. So post that in the chat channel. Meanwhile, there are a lot of problems when you have agents and you're wanting to make them securely. What do you think of some of these, Jeroen?
I think the major issue today, when we're talking specifically about security and agents and all of the ecosystem and the digital infrastructure that MCPs, servers, and agents actually interact with, is that we have different expectations for these types of systems and what we'd expect from, let's say, regular humans. And so you can see some of those in the list here, right? We're talking about, for example, let's take the middle one, no identity, no audit. We would never accept to, hire an employee into an organization, but not be able to track, what they did and when and which systems they access. There's a tracking system for pretty much all digital access. But when it comes to agents and MCP server, it looks like we're deploying things into production and we're going, oh yeah, that's a second concern. We will deal with that later. And then also revoking access, right? This takes a very, very long time. It took a lot of time even before agents and MCP servers came up. But now when you're connecting databases and API servers and CRM systems that hold customer data into your agents and MCP servers, if you have any form of breach, you need to be able to revoke access immediately. And all of your downstream workflows that are happening based on that should essentially immediately stop if you have any form of poison data. Also with prompt injection, prompt injections can actually cause MCP servers to unknowingly access way more information than they would. This is a problem that's actually not really happening in distributed systems before MCP servers did, because now you have a very non-deterministic way to create SQL queries on demand and essentially give access based on whatever the attacker formulated in their prompt that they want to get access to. So this is a problem. I'm going to give a Lord of the Rings example, and my team at Diagrid is probably going to go like, you're a sellout. You always tell us how Lord of the Rings isn't the greatest movie of all time. But there was one pretty good example there. It's when Frodo gives the one ring to Gandalf, and he asks Gandalf, why won't you take the ring? And Gandalf says, well, I would, but through me, it would yield much more terrible power. It would essentially amplify. And MCP servers are the same thing. You want to use them for good, but through them, you actually give unmitigated access into your entire kingdom.
Yeah, so there's a lot of work to happen inside here. And I think some of these examples inside here where you can compare agents today with what we've been doing for humans kind of leads on to really what really should be the basis of the entire system, and that is identity. And identity is kind of key. And what we've been doing is we've built identity systems that are great for humans, give access right to these files, this directory, things like this. And we've also built identity systems that are pretty good for deterministic business processes, where you know exactly in advance what they're going to access, you know exactly what they're going to do, and you know exactly their behavior. But, those are sort of static accounts that you give with API keys and service accounts. But agents aren't like that, really. I guess they're a little bit more like human. Like you have to kind of give them a passport because they might go off and do particular things. They need some identity about who they are. And of course, the access control rights can be broad across all sorts of systems. So at this point, the question you should be asking yourself is, every piece of data an agent touches, is it allowed to? Is it a question of entitlement? Should that agent have even seen this? Because they're non-deterministic systems. And I think that's a good topic to talk about, Jeroen, yes?
Yeah, I think the whole concept of just-in-time is becoming way, way more important in the age of AI. If we were ready to accept that, systems have a very defined scope and that we can measure and decide what that scope is and give them the access they need based on that in AI systems, you really want to be able to put just-in-time access. Because again, because of the non-determinism you just mentioned, the scope of the queries or the request into the underlying systems that they request, that can grow and change based on things that the system didn't necessarily plan for. Because in the end, we're talking about LLMs, which are black boxes shooting back the response to their queries. Even if the temperature is set to 0, you'll get vastly different queries that essentially can create SQL queries to your Postgres or MySQL or T-SQL server database on demand. So just-in-time becomes really important. You need to be able to provide guardrails to see if the agent actually needs the access that the system said it does. And if it does, you want to give it the access, but then block it out because it might be serving other systems who don't necessarily carry the identity of the entity that does require access to that data. And so really every piece of data that agents touch through and with MCP servers should be questioned all the time. And this is really where zero trust, and we'll demo this, comes in.
Yeah, I think zero trust is the great way of describing this, is that we've understood and talked about zero trust systems for a long time, but they've always been the deterministic side. And I think companies and organizations are wrestling with, what does it mean to give zero trust to an agent? And without an identity around those things about what it is, just like you have with a person, then you're effectively opening yourself up to all sorts of attack vectors.
By the way, I know I mentioned Lord of the Rings before. If anyone in the chat can tell me what animal this is, then, well, you're not going to win anything, but I'm going to call out your name and give you a thumbs up. Free question. It's not that simple. All right, I'm going to talk about this slide. So in agentic systems, we might be able to argue that, look, what got us here will get us there, but that's actually not the case. At my time at Microsoft, I actually read a book that's titled What Got You Here Won't Get You There. And it's very much true for authentication. The same primitives that gave us the ability to decide who gets access to what, not when, but who gets access to what, are simply not sufficient for the age of AI, because we need to know which agent made the decision. We also need to know why, but let's start with which specific agent made a decision. And in a workflow that comprises many steps and many actors, we need to know exactly what chain of events led to that specific outcome. And was this action approved by a policy at runtime? And can the agent actually prove through cryptographic means its access across systems? This is especially important in financial services and regulated environments. And then we want to enable downstream services to be able to verify the provenance and the intent. What got us here, client IDs and auth 2 does not provide answers to all of those. What we need are cryptographically attestable identities that can carry across systems, can be audited, can be viewed and be non-tampered with. They need to be able to be delegated across workflows, and operators need to be able to tie their execution history and policy context. So it goes way beyond authentication, because you can't simply think about who this thing is or what it can do. You need to think about how does it interact with the whole workflow and the whole system, and be able to draw this lineage. And this is really where the ecosystem needs new primitives in play. And there are attempts. If you haven't heard of AUth, that's the agentic side of OAuth. It's an up-and-coming protocol. There is that's coming. It's not going to solve all the problems that I just talked about. It's essentially just a better way to represent a static identity for an agent with extra information. But when we really talk about identities, we cannot separate them from access policy, because an identity is really only useful if you can then enforce policies and rules on it.
Yeah, exactly. So the cryptographic testability and the assignment of identities is critical to this, coupled with the fact that that then goes through to the authorization about what they can do.
No, Cassie, this is not a hippogriff. This is not a hippogriff. Try again. It's difficult. Yeah.
So then when we, so kind of let's look at one area that people are being very excited about. Back in March, actually, I went to MCP DevCon in New York, and I talked to a lot of the vendors there, and I saw that many people were building and putting together MCP gateways. And the answer is well, MCP gateways kind of partially useful. They give you a wall. They give you a wall around the thing that you're trying to protect, but in the end, what they do is that they still go down that OAuth direction. They're not really anything to do with identities themselves. And if you breach that wall, you get inside the castle. You can steal the crown jewels. You can do whatever else you want around these things. They're not identity systems. They're just castle walls are enough that if people get inside them all, they don't really do much for you. So you can utilize them, you can look at them, but they're not even closely enough to doing anything to do with zero trust security in your systems. And I think people understand this, but I think they're just using them as patches today in many ways, and you've got to figure out how you move on beyond these. What would you add to this, Jeroen?
I think this drawing is actually pretty spot on because it represents the wall, which is like the north to south access into your kingdom. But once you're in, you're essentially able to really go anywhere. And MCP gateways, they operate at the network level for the most part. And that's just not enough because you need to be able to peer into what's happening and you need to be able to play a role in the broader workflow of things. And so MCP gateways essentially being north to south, very network-focused types of infrastructure plays are simply not enough. They do not give you the cryptographic attestation that you need and are able to carry it across the workflow. So they're good. I'm not saying you don't need that, but it's just not enough. And today in the demo, I'll show you a few things that MCP gateways simply just cannot do.
All right, well, let's build up the things to get to the demo then, and let's just put a few things in place.
I'm going to share my screen and take it from here.
Yeah, why don't you take it from here?
All right. And before I do, yes, Ravi, indeed, same for agent gateways. So I'm not going to give a hint. I'll just tell you what this animal is so we can get that out of the way. Yeah, it's called an owl bear. It's specifically from the world of Dungeons and Dragons. Okay, it's not one animal, and it's fictional. It's an owl bear. Yeah. This is what it is. It's pretty cute. Google it up. I mean, you wouldn't want to run into it if you were living in that world, but yeah. All right.
I believe you.
You believe me? Yeah. Okay. Let me know if you can see it.
Yep, we can see it.
Great. Okay, so today we're going to be talking about Spiffy. I kind of wanted to change this slide just to be more specific-centric, but I can just talk to it, that's fine. So inside of Dapr, which if you don't know what Dapr is, it's a graduated SynCif project, which allows developers to write durable workflows, do service invocation and pub sub without needing to focus on the reglowing. And Dapr uses Spiffy, and Spiffy is a sister SynCif project that essentially provides identities in a specific format, and those can be incorporated into JOT tokens or X509 certificates. And so Dapr, from its first moment, actually had a certificate authority in it that provided those types of certificates with embedded identities to every actor in the system. When I say actor, I mean any application in the system. So Spiffy gives us the identity mechanism. Dapr, anytime you connect an application to it, essentially creates this cryptographically attestable certificate that contains the Spiffy ID, and it just distributes it into the workloads. This is globally unique. There are no secrets aligned to the application's lifecycle. It's all being handled by Dapr, and it's being used for many things in the Dapr world. When you're talking between services, or you might be talking between agents, Dapr uses those certificates to essentially do MTLS. Inside of the handshake propagation step, it extracts the underlying identity, and then it sees if there's any policies, like access policies, for example, which we'll see today, that have been defined, and then it basically says, okay, I can trust this identity to call my application, and I'm going to enforce some rules on it. So this is just a great way you can connect any form of application to Dapr, and we really extend on the spiffy concept by in Dapr coming up with our own one, which is called an app ID. And again, an app can pretty much be anything. Once you have your application connected through Dapr, Dapr will issue that certificate for you, and then you can go ahead and from the platform perspective, put declarative policies on pretty much anything. Today, we're going to be focusing on how you can use this for MCP and agentic workloads. We're going to take a look at Catalyst, which is our commercial platform. And Catalyst is essentially built on top of open source software. So it's built on top of Dapr, Kida, Spiffy for sure, gRPC, OpenTelemetry, and many other projects that we've incorporated in it, and we'll see how you can actually govern that access. So this is what it would look like. If you were either using Catalyst or Dapr in this case, you would have your application. It would connect to Dapr or Catalyst. It would then issue a certificate that contains the embedded identity for that specific agent within it. And this is essentially your security boundary. And as I mentioned before, identities can be created for anything, pretty much any piece of code that you connect to the Dapr API and by extension into Catalyst can provide you with this identity. So an identity is only one piece of the story. What do you actually do with it? This is where you have access policies and really coming into play. Let's say we have agent 1 and we've got it talking to an MCP server here on the right and also an agent 2. We are in this environment, assuming that all of those different actors like the MCP server and the 2 agents have connected to Dapr. We've issued their identity. And so from the Dapr perspective, these are tracked entities. We have a life cycle of workloads. Dapr and Catalyst, which is the Dapr platform that we have here at Diagrid, we continue to rotate those workload certificate on an interval that you can define. And in these 2 YAML examples here, you can see how we provide an access policy to essentially deny all access to an MCP server. But when it comes to communication between agent 1 and agent 2, we are denying everything but allowing access only to agent 1. So let's stop talking so much and take a look at a demo. And this is what we're going to see. So I have a system that is running fully locally on my machine. We have this on GitHub. We will have the link for you at the end. You have 3 agents here. We have an ops agent, and an analyst agent, and an admin agent. And we have a single, this looks like 4 different MCP servers, but it's actually 1 MCP server with 4 tools. So we have one tool that writes the database, another tool that gets a schema, another tool that queries, and another tool that can drop tables and delete records. And it's connected to a Postgres database. And what we're going to do is essentially show you how easy it is to, in one CLI command, enforce a complete blanket zero trust policy across our entire system, and then work from there to gradually give access into different personas and entities in our system. But it's not just that we're giving access, we're giving extremely granular access, and we can provide identity to pretty much anything here from the agent all the way into the actual database and even scope access to that. So that this Postgres instance, for example, can only be used by certain MCP servers that are getting called by specific agents. So you can go as granular as that. Yeah, so let's switch over to VS Code. Is this zoomed in enough, Mark?
Yes, that looks good enough. Yes.
Okay, it's really zoomed in on my front, so yeah, it'll be a bit difficult, but we'll make do. So what we have here is a GitHub repository that contains a bunch of agents. These are the agents I talked about. Looking at their code is not important. These are not necessarily agents that are doing anything interesting, except they're trying to talk to the MCP server and get access to the different tools that they're trying to get access to. So I'm not going to spend too much time on their code. I am going to spend a little bit of time on this MCP server. This is a regular MCP server. It's just using fast MCP, which I think is the most common framework today for writing MCP servers. As you can see, there's nothing Dapr here. There is nothing Catalyst specific. We essentially have 4 paths here. So we're mounting 4 paths: write, schema, query, delete. Those agents are going to be trying to connect those. And yeah, they each have their own business logic. This is real stuff that's happening. They're connecting to a Postgres database that they have running locally. So I can do PG's ready. I have this database listening on the default port here on my local machine, and each one of those tools have its corresponding business logic. Great. So now after we do this, I am going to use the Diagrid CLI command, which you'll see in a sec, to essentially connect to those MCP servers and agents and connect them to each other. So this is not running in Kubernetes. The CLI command just allows me to connect to the Catalyst, in this case, security engine, which is going to be the one that's enforcing the policies, and really tunnel all the requests back to my machine because everything is sitting here locally. This will become more clear as I actually run this thing. So let's just start with this first Diagrid run command. And while it's starting, I will explain exactly what this is doing. If you know Dapr, you know that you have Dapr run. It's a CLI command that allows you to run the Dapr process and your application. So this is just the project that I have. In Catalyst, you can create different projects and assign people to them. And the MCP server is running. So let's continue with this. You give it an app ID, right? This is the identity that's actually getting created. So at this point in time, you can do this individually with your own CLI command, but at this point, we've created an identity. It's created a certificate with an embedded SPIFFE ID for this MCP server. And the one last important thing here is that this is like a helper method, essentially telling it to also run my Python app. I could not use, I don't have to use the Diagrid dev run command. I could just do Python server py and bring in a few environment variables to tell it how to connect to Catalyst Cloud, which is our SaaS offering. We also have a self-hosted offering, but this is connecting to our cloud offering. So we've got the MCP server running here. If I go back into the UI and I go into app IDs, I can see that we have MCP server here, and we see that we have the API token, and this is actually the app ID that I have. We can see it here, and we'll get back to this after. So now that we have the MCP server, we can start running the agents. Actually, before running the agents, let's do the zero trust policy. It's already enabled, but I'm just going to do it again. So I'm going to do Diagrid apply, and I'm going to look for the deny all. So I just applied a YAML file called deny all. This is the only thing you need to do to apply a zero trust policy that now is stopping every form of access into that MCP server. So,
and that's like the policy that you looked at earlier, yes? I mean, it would be
this is it. Yes, this is exactly what I'm showing. So this is what I just applied. It's a simple configuration policy. This is really all you need to strict anything. No agents, no allows, nothing is able to connect it. We just have a default action of deny here. So what we will do now is here, we will try to kick off a Diagrid dev run command for one of our agents. Let's kick off the ops agent. This is an agent that is trying to access, I think, 3 out of the 4 different APIs. And what we can see is that the agent is reporting back that it's blocked. So this is an ops agent. He has day-to-day operations. It does read-write. It does everything except for try and delete. And it's trying to inspect the schema, but it can't. It's trying to register a new customer, but it can't. Trying to confirm that the customer was inserted with the query tool, but it cannot. And this is because Catalyst essentially mitigated and prevented all access with this simple YAML file and this single line of code to the actual MCP server. Let's kick off.
Yeah, but just say, so just so we're clear, I mean, what this means now is you can define your MCP servers, you give them an identity, and then kind of as a platform team, you can apply policies to them that control who and what has access to those. You have complete control over whatever other things have identities running inside the system, yes?
Yes, and I've just launched the supervisor agent, which is the one that has admin access, full system access, including delete, and it was blocked as well. Now, all or nothing blocks are great. I mean, they're really, really important, but we talked about granular privileged access. So I'll show you how we can do this, and I'll also talk about how you can use this for just-in-time agentic access, which I think is really, really important. So now that we have this, we are ready to move on to the second phase, which is what I would call gated trust. So I will just do Diagrid apply again, and we will do phase 2 allow. So this is going to kick off. And now we're going to take a look at a YAML file that is, again, very simple to understand and also very powerful. So in this case, we're still saying, look, the default action is to deny everything that's coming in, but this is what we expect those specific agents to do. So the ops agent now has access into the write tool that we saw in the MCP server, and it has access to the schema tool and the query tool. The analysis agent has access only to these two specific tools, and the supervisor agent has, well, pretty much access to everything. And then what we can do is when it comes to, just in time, we do have APIs and CLI commands for you to be able to get more information about the system. When the identity of the caller is being propagated into your workflow, you can grab it, you can see who that is, and then you can basically make programmatic decisions and be able to apply those policies again. So you can basically say, look, I've just served this request for the analysis agent. That's great, but now I'm actually gonna shut it off because I don't want to give access to the analysis agent all the time. I basically programmatically want to be able to decide when I'm going to give that access. So because Catalyst and through Dapr is runtime configurable, you can apply those policies also on the fly. All right, so now we have this access policy enabled. Let's try and do the Diagrid dev run command again. And again, this is the same command that's essentially just connecting our local Python file to the Catalyst instance that's governing and proxying all of our calls. And what we can see here is exactly what we'd expect to see. So we have 2 out of the 3 calls allowed. So now we can inspect the schema, and this is what we're getting back. This is allowed. That's great. The agent flagged this as happening in the way it would expect. We can register a new customer, so we use the write tool for that. We confirmed that the customer was inserted, but we were denied the delete access, which is exactly what we defined inside of our access policy. So this is extremely granular access that can be used to perform CQRS. If you're familiar with that term, just from the regular, microservices world, where you can have some workflows that do read-only, you can have some workflows that do write-only, and then you can also go very granular into exactly what they provide. Now, in a future webinar, we'll also show you how you can get even more granular than that. And on the MCP server side, make sure that the MCP server only has access to specific tables within a database or specific collections within a database if you're using something like a key value store. And that is the next level of granularity that you need. You need to protect the entire thing. Dapr can actually protect the data also. This is by using its state API. We will have more examples and more documentation on that going forward.
But Jeroen, if it just kind of going to pause you here a moment, if you kind of go and look into the UI at this point for the Catalyst portal, at this point you can actually see the IDs here for the agents themselves.
Correct.
So, and you also see the IDs for the MCP server that you launched inside here. So it's just good to kind of show the agents running inside here with the IDs.
So all of those agents that I launched, because I was essentially running Diagrid dev run, it created the app ID for me. And by creating the app ID means it creates their, let's call it virtual projection here. And once you have those app IDs created, you can essentially just use them to front anything that you want specifically. So the agents use their access to be able to prove who they are to the MCP server, and the MCP server essentially has knowledge about the identity of everyone because Catalyst through Dapr is doing the handshake and verification of exactly who is calling who. The only missing part that you have here is that to configure your agents to actually talk to their Catalyst counterparts here is you need to set the environment variables for them. And this is a combination of just taking these 2 environment variables and taking their API tokens. The Diagrid dev run command does all of that automatically for me.
Yeah, and then if you look at the policies as well, I mean, the policy that you set inside there is this MCP policy inside here. So you can see the policy view inside here.
If we go and take a look at that, then we can see all of those different policies. You can see the YAML. This is exactly the YAML that I presented. You can also get access to those programmatically. And something really nice for auditing and compliance purposes, you can actually see all of the audit log here, and we can export those to you, right? So, by the way, we we should be using outbound request for where it says request and request for outbound request. It's a UI thing. But this, for example, is the ops agent that was trying to invoke the MCP server. So you can go into here and you can see exactly the error that it got back when we were trying to access it, when we had the zero trust policy enabled. And yeah, you can see the status, the agent, you can get the trace ID and the span ID. So you can really correlate this to your existing tracing backends. You see the user agent, the IP address, and any log levels that you have associated with that.
And then from a topology perspective, you just got the apps graph, which just shows a view of just the identities themselves from a graphical perspective. If you
yes, we'll go to that in a sec.
Okay.
Just look at the API log here for the MCP server. So this is what an inbound request would look like. You can see exactly who tried to contact you, and these are cryptographically testable. This is not a magic client ID stream. Yeah.
That's pretty cool to see the IDs there.
Yep. I don't know if the app graph is gonna work. Yes, it works fine. So I essentially launched this. It's not really a workflow in terms of Dapr workflows. I launched these agents stuck in the MCP server locally, and what we did in the backend is we were able to plot all of the access from those servers agents into that MCP server. So you can actually get a view of how your system behaves in real time. And you can also further isolate them if you want to. You can see the error rates, the latency, and the request per second that we had. This is all gonna go down to 0 because it's showing the last, I don't know, like a minute or so. But you can see the real-time metrics here, and we also have APIs that can return you those metrics. So we kind of like are overlaying distributed tracing and metrics together in a single view. And if you used Catalyst to connect your MCP server or any of your agents to a, let's say, pub sub-broker or a database, you would actually see that appearing in orange here. And you would see the underlying database, and you would be able to see exactly who is talking to who. And if there are failures, you would see them here in real time as well.
So okay. Yes, you've got this pretty cool view. You've got identities assigned to things, and that's just the flat list. You can see a topological view of how they relate and interact. Then you can see the policies that are applied to each one of those. And then you can actually update the policies dynamically on the fly and see how they affect the behavior of the overall system.
Yep. And this is an example of an agent that we have. So the policy that we applied only applies to the MCP server, but we can just click on add new configuration here. Well, we could apply the same MCP policy. That wouldn't be right. But you can essentially just apply the Dapr YAML files for configuration here and assign them. And you can also create them right from the UI, right? So you can go here, you can do new configuration, you can give the name, and then you can start doing global default actions, on deny if you want to restrict a call to the analysis agent or allow a call from the analysis agent. This is how you do it. We automatically populate all of the different entities in your system here. So we've got analysis agent, then you can say, look, it is able to get the, I don't know, right schema. It's able to enable the right schema API for the post verb. And this is essentially how you go ahead and do that. Yeah, and you can put as many of those as you want. And again, you can put them for callers, you can put them for callees, and you can use them for pretty much anything. They can be used for applications that are being invoked inside of workflow. They can be used for MCP servers, MCP clients as well, HTTP servers, gRPC servers, you name it.
And while you're here, we might as well just look at the MCP server view list you have inside there under develop, and it just shows you effectively a way that you can actually register a catalog of MCP servers, yes, and just put something inside here.
Yeah.
We haven't got anyone in here at the moment, but this is how you would kind of set up an MCP server you can use in the first place as well.
Yes, in this demo, I didn't register my MCP server, but if you're a platform team, you need to govern access and essentially put access policies on very explicit MCP servers. This is how you'd go about it. You'd click on create, and again, this has a YAML form and CLI form. You'd start off with a name. It's called my MCP server, not that original. You can choose the transport, the URL for it. You can choose the authentication that's happening. And by the way, this is enforced all the way through Catalyst via Dapr because we have the SPIFFE identity. If you don't want to use SPIFFE necessarily, we can actually connect into your existing OAuth 2 and OIDC providers. You can essentially just provide the scope, the issuer, and the audience here. Give us the secret store where we want to fetch the client credentials from, and you're essentially off to the races. There's essentially a few more fields that you can put here. The YAML version of it has more than what you see in the UI. This is actually a feature that's coming out in Dapr 1.18 that hopefully will get released within the next 2 weeks, but we're already putting it inside of our managed offering.
Yeah, so that's kind of pretty cool. And just kind of why you mentioned the OAuth, that just in many ways, that's kind of what those MCP gateways do. They do the OAuth, but they don't go past identity. So it's kind of great for the entrance, but not beyond all of that.
And I talked before about being able to extend this all the way from the agent into the, for example, the underlying database that it uses. This is going to be the topic of a future webinar, but you could onboard all of your digital infrastructure through Catalyst. So in this case, I'm actually adding a database, and what we're going to do is we're going to treat this database as if it's its own identifiable entity within the system, and we can put scopes on it. So in here, let's say we're choosing AWS DynamoDB. We can click on continue. Now we can choose exactly which agents and MCP servers have access to that database. And this is really important because you might be able to say, okay, only the MCP server has access, but none of the other ones do. If you have applications or agents that you're going to be launching in the future, you can put their IDs in advance here so that they can get added retroactively.
That's pretty cool. You've got your agent application and your MCP server, and the MCP server controls what it talks to. And then you've got the underlying infrastructure itself, and you can control which MCP servers actually communicate to that as well. So you've got another level of control over the access right.
Correct. Now I'm just creating this component that doesn't exist, so I think it should actually error out because I'm just putting nonsense in. But this is essentially the YAML that it creates for you. No, this is just a Dapr YAML. You can just do Dapr applying to Catalyst and it'll just work. Now I'm going to save this, and yeah, maximum number of components. So I have too many in my project. I should ask my team for more. But we can actually take a look at an existing component. So it would appear here. And we've got the KV store here. And at that point in time, we can actually start testing it out, right? So this is really, really cool. Let's say you onboarded that DynamoDB database. In this case, we're using a Diagrid managed KV store that we give you, which you can use for free. You can actually put the key here, and you have the curl command, and you can essentially just start making operations. So let's do a post, so you can put the key of the value, and you can essentially just talk to your database directly through this UI, and I think we also have a CLI for this. So this is a pretty useful thing for debugging and for understanding if your system is actually behaving. So for example, every component here, we track the health of. So if I did end up adding this DynamoDB database, you would see that its status would have been not ready, and it would have shown us the exact error. So this is a great way to just onboard infrastructure and see if there are any configuration errors before we actually deploy our applications, and find this out when it's too late. And by too late, I mean when we're already running in real time.
Yeah, so that means as an operator, I can deploy infrastructure, databases, message brokers, other things like this. I can then set up an MCP server as well if it's fronting that infrastructure, and then configure that. And then I'm ready to go. And then I can allow particular applications, agents, whatever it is, to access that. So I kind of got those 3 levels of control.
Yes. Let's see if I have a few more interesting components here. Okay, I've got a lot of components here. This is an example of, let's say, OpenAI. So Dapr and Catalyst also have a conversation API that has a bunch of really interesting security features, because we're on the topic, like PII data reduction. Yeah. So what you can do is you can talk to things like Mistral or OpenAI or Anthropic, and you can actually ask our system through the conversation API to remove any information that is going into the LLM or going out of it if you're training your own models. And you can tell it to essentially pick out phone numbers, credit card numbers, social security numbers, all of that stuff. And this is how you would go about putting the configuration here. Again, it's a simple YAML file. You've got conversation.openai. It's talking to OpenAI in this case. And so this is also a really great way to know if you have problem connecting to OpenAI upstream, because once you put this YAML there, before any application even starts using it, we will validate the connection and we will flag to you if the key, for example, that you put is being throttled, or if it's exceeding anything, and if there's connectivity problems, if you input an endpoint that doesn't exist. And this is true for pretty much any form of infrastructure that you can onboard through Catalyst.
Let's get back to your demo.
My demo is done.
Oh, okay. I thought you'd done your final type of access policy.
Yes.
That was it. You gave it all.
Mm-hmm.
Oh, okay. All right. So you went through it all. Well, actually, we got a question here that came from Ravi. He just asked, can Dapr/Diagrid do MCP custom transports?
So today we support standard IO, we support HTTP streamable, we support HTTP, what's the name? Escaped me. The thing that came before streamable. So we support 3 of them. Yeah, someone put something in the chat. SSC, streamable, HTTP, and STDIO. Thank you, Sam. So yeah, we support those. When you're talking about custom MCP transports, what do you mean? If you're specifically asking about the upcoming gRPC MCP transport, then we will provide support for that as well. Yes.
Yes. So great demo. It kind of covered a lot inside all that. I mean, as I just kind of put the picture back over here at the end again. It shows that you have, I mean, here we show this broken out into 4 MCP servers, but you just did 1 with different access rights to their tools, and then 3 different agents to the Postgres database. And applying that policy dynamically allows you as an operator to effectively have complete control over the system. And that's where it comes from. Yes, it's the platform team that needs operations on these things.
Indeed.
All right. Well, if there are any questions, continue to post them inside here. Kind of meanwhile, there's one other topic we were going to talk about, and that was trust domains.
Yes, trust domains are really important. They allow you to essentially create groups of specific agents or MCP servers or pretty much any application, and be able to define that you want to allow to have implicit trust between, or explicit trust really, between a certain group domain and another, but you want to disallow any form of access from another trust domain, or any form of entity that sits outside of the trust domain. Mark, you just flipped the slide, but yes, if you can stay on that, that'd be great. So in this example, what we can see is we have trust domain called TD1 and trust domain called TD2, and TD2 to the right has agent 3 and MCP server, and they have trust between them, but there is no trust between anything that sits inside of trust domain 1 and anything that sits inside of trust domain 2. And this can have as many logical applications that you want inside of it. And we also have the example of agent 1 that has no trust domain, but we can configure it to have access to both. So it's just a really great way to group different entities together based on any form of logic that you apply to it.
Yes. All right. Well, let's start to wrap things up a little bit here.
Yep.
As we demonstrated today, Diagrid Catalyst is our agentic AI agent orchestration platform. It is all about bringing security and resiliency and reliability to your agent applications. The way we look at this world is, if you go and watch our previous webinar, we actually built a LangGraph agent in that and brought reliability to it all. So you can bring any of the agent SDKs today and build on top of that and deploy your agents. And then today we kind of went through the security policies that they would access effectively and going through MCP servers. So look at Catalyst as that durable workflows for the durable execution, and then the authentication and authorization with a whole governance and around it all. That on top sits on top of your infrastructure. And if you sort of dive in a little bit more around this, we have these sort of 4 pillars that we talk about. We're very much covering the security and governance one today. We sort of just touched on many of the features inside here. We also talked about reliability in our previous webinar. This is the one, if you want to go back and watch this one here, it was this one here, is can your AI platform do this? LangGraph with Dapr, the combo that survives production. A great talk where we covered bringing resiliency to LangGraph. And we're going to pick something else to talk about next. Who knows what? We'll probably dive into more on the reliability section next. There's plenty to cover in what a platform needs, particularly when you start to talk about communication between these things, understanding what having an agent's done and monitoring around these things.
I think with Dapr 118, we're going to have something that is appearing on this slide, and probably not many people are giving it much attention, but it's called attestation chain of custody. This is a game changer, and we will do a webinar specifically for that to show you exactly what you can do with this, because this brings the worlds of durable workflow execution and security together.
Yes. So maybe that's the topic we pick up next. We'll be doing one next month. A month from now, we'll be in June. Look out for the webinar. We'll be posting that. And if you want to try this out, you can go to this particular repo here. It's this one, GitHub/Diagrid Labs/Catalyst/MCP access. It's this particular repo here that Jeroen popped up last night. This is the demo that you just saw.
Not last night, 1 hour ago.
Okay, 1 hour ago. You can also dive a bit more into our documentation here on Catalyst, where it actually goes through a how-to as well. Same thing inside here. And of course, we're here to answer questions. We had our emails at the top, either Mark or Jeroen at diagrid.io. Feel free to send us an email anytime, or jump onto our Diagrid Discord server. Here's the link. We'll post these links inside here afterwards. In fact, I'll post this link now inside the chat window to this repo, so that you can actually grab that here, and then we'll post the links into the Discord channel later as part of all of this. But great having you all today. Hopefully you took away from this that identity is the basis of entire secure systems, and agent identity is the key to being established if you want to build that zero trust applications. Catalyst is a great platform to start it off with. Where we look at this conjuncture is that there are many products out there who are bringing you sort of durability around these, or attempting to inside of workflows. There are a lot of people talking about security and agents, many companies, but you need to be able to bring those two together. And you need to be able to bring both the worlds of security, identity, along with the reliability if you want to build true agentic systems and take them to production. Anything you'd like to add, Jeroen, at the end?
Nope, just that owlbears are cool. That's all.
All right, with that, thank you for joining us today.
Thank
Excited
you.
to have you. We'll see you in a month's time. Watch out what we're going to post about. I guess we're going to be going down a bit of reliability and a bit of attestation next, in terms of talking about, can your AI platform do this? Thank you.
Thank you, everyone. Bye.
Bye-bye.